In this video, we're going to look at how to determine the molecular geometries for organic molecules. So organic molecules are generally considered molecules that contain carbon atoms that are covalently bonded to some other non-metal atoms. And these molecules are very important because they're essential for life, and so therefore it's important to understand their structures, shapes, polarity. And a particular note about organic molecules is that most of them have more than one central atom. However, we can still use the rules for determining molecular geometry that we've learned previously and apply those to determine the molecular geometries for organic molecules. So a few general steps here for determining molecular geometries for organic molecules. First, we always have to draw the correct Lewis dot structure or electron dot structure for that molecule. Once we have that, we pick one of the central atoms. Let's say we have 2 or 3 central atoms. Pick one central atom and determine the electron domains for that particular central atom. Then determine and draw the molecular geometry and electron domain geometry for that central atom. Then repeat steps 2 and 3 for each additional central atom, and then we join those shapes together. So let's work a few examples to help illustrate what we mean by those in those steps. So let's draw the molecular shapes or molecular geometry for the following 2 molecules, C2H6 and C3H8. Pause the video and see if you can draw them. Once you have drawn them, then we'll go over them together, and you may need to use this table of geometries when you're drawing your the shapes for those organic molecules. So pause the video and give it a try.
Okay, so for these 2 molecules, you can see we've already drawn the electron dot structures. Now we've done this in a previous video lecture, so you may want to review that if you have questions about the dot structures. So once we get the electron dot structures, let's look at C2H6. We have 2 central atoms. So we pick one of the carbons and we count the electron domains or the steric number. So for this carbon, the first one here, we have 1, 2, 3, 4 single bonds, right? So therefore we have 4 electron domains. We have a steric number of 4. So a steric number 4, all of these 4 are single bonds. That gives us a tetrahedral electron configuration around this carbon. So we've got a carbon, and then remember with a tetrahedral shape, we have 2 bonds that are generally in the same plane of the screen. We have one bond that's coming out and one bond that's going away from us. So I'm going to put a hydrogen up here. I'm going to put the carbon-carbon bond right here, and then a hydrogen and a hydrogen here, right? We've got a carbon bonded to 3 hydrogens and 1 carbon. So that's a tetrahedral shape. Now we look over here at our second carbon. Again, here we have a steric number of 4 for this carbon. All 4 of these, 1, 2, 3, 4, are single bonds, no lone pairs. So this molecular geometry around the second carbon is also tetrahedral. Now with a tetrahedral, again, we're going to have 2 bonds that are in the same plane, and those bonds need to be about 109 degrees apart. Now, not 90 degrees apart. So you can see we've got one here. So I'm going to draw this one kind of going back a little bit, and that should be roughly about 109 degrees. Now we're going to have one of our bonds coming out and the other going away. So we still have 2 bonds in the same plane, a bond coming out and bond going away. And all 3 of these are going to be hydrogens, right? We've got 3 hydrogens bonded there. So we have our carbon-carbon bond here, hydrogens, 3 hydrogens, and a carbon-carbon bond here, and 3 hydrogens. So now there are certainly more than one way to draw this molecular geometry, but there are certainly certain things we have to key on. For tetrahedral, we have to have our bond angles about 109 degrees apart, the ones that are in the same plane. We have to have a bond coming out towards us, a bond going away. So that's some general rules for tetrahedral. But again, there's more than one way to draw this, but this is a pretty good start. Now let's look over here. With this carbon, we pick one carbon and determine its electron domains. Here we have, again, 1, 2, 3, 4. So we have a steric number of 4 for this first carbon. All of these are uh, single bonds, no lone pairs, so I know that's going to be tetrahedral. Okay. So I've got kind of the same start as with the other. So I've got a hydrogen here. This is going to represent my carbon-carbon bond. A hydrogen here and a hydrogen here. Okay. Now let's look at the middle carbon. Again, we have 4 single bonds, so 4 electron domains, a steric number of 4. All bonds, no lone pairs. So again, look on that table and you'll see this is a tetrahedral shape. So we need these bonds that are in the same plane, 2 of them in the same plane. That's about 109 degrees apart. We're going to have a bond coming out towards us and a bond going away. So let's put that bond in the same plane. Let's make that our carbon. This will be a hydrogen, hydrogen. So this carbon has 2 carbons bonded to it and 2 hydrogens. This carbon has 2 carbons and 2 hydrogens. So we have to pay careful attention. We've got everything bonded correctly. And then our third central carbon, again, a steric number 4. You can see that. We have here we need a bond in the same plane, a bond going out, and a bond going away from us. All 3 of these, we have 3 hydrogens bonded to this carbon. It's a hydrogen, a hydrogen, a hydrogen. So we have a carbon-carbon bond, which we have here, and then 3 carbon-hydrogen bonds. Okay. So again, there are other ways to draw it, but it should look something similar to that. Okay. So these are our molecular geometries. Again, what is the molecular geometry for this molecule? That's not an accurate statement. We have to take a look at the molecular geometry for each individual central atom, and then we piece them together. Okay.
So now that we've shown you how to draw the electron dot structures for a couple of fairly simple organic molecules, let's try a few others. So let's try to draw the correct molecular shapes or molecular geometries for the following 3 organic molecules. Pause the video, give it a try, and then we'll go over it together.
Okay, so you can see here we have our 3 molecules, and we've already got the electron dot structures drawn. We've drawn these, shown you how to draw these in a previous video lecture. But we want to look at our molecular geometry. So let's look at our first molecule over here, CH3OCH3. So we take our first central atom, in this case the carbon, and you can see we have 4 single bonds around the carbon. So that first carbon has a steric number of 4. So 4 bonds, no lone pairs. So that carbon is going to have a tetrahedral molecular geometry. So we have 2 bonds in the same plane, 1 bond coming out towards you, 1 bond going away. We've got a hydrogen. We've got an oxygen bonded to that carbon. I'm going to put the oxygen there. And then we have 2 other hydrogens. Okay. Now let's look at our oxygen. This is a central atom. This has 1, 2, 3, 4. It has a steric number of 4, but it has 2 bonds and 2 lone pairs. So look on your table and see what is the molecular geometry for that. Well, 2 bonds, 2 lone pairs. That means we have a bent configuration. So my oxygen is going to be bent. Now with molecular geometries, we don't have to show the lone pairs. We do on dot structures, but we don't on here. So I'm going to leave them off. If you put them on, it's not incorrect. Now, here is my other carbon, my third carbon. We have 1, 2, 3, 4 bonds to there. So of course we know by now that's going to be tetrahedral. So I've got my carbon. I'm going to have a hydrogen, 1 coming out, 1 going away from you. So here we have our molecular geometry for this molecule. Let's look at our other second molecule. Start with your first carbon. We have a steric number of 1, 2, 3. Remember, a double bond is 1 electron domain. So here we have a steric number of 3 for that first carbon. So that's going to give me a trigonal planar molecular shape. So we have a hydrogen here, 2 hydrogens. Then we have our carbon-carbon bond here. Now you can draw this as a double bond or a single bond when you're drawing molecular geometries. I'm going to draw as a double bond, but if you draw it as a single bond, that's correct as well. Okay, but I'm going to draw a double bond just so we're clear on what we're talking about here. So this is the correct way to draw a trigonal planar shape. Now let's look at our other carbon. Our second carbon, we have again 1, 2, 3 electron domains around that carbon, so we're going to have a trigonal planar shape there as well. So we got one bond going this way, one bond this way, this way. Again, they're all about 120 degrees apart. And then my chlorine. Now we don't have to include the lone pairs around the chlorine with molecular shapes. So this would be the correct molecular shape here. We've got trigonal planar around this carbon. Again, everything is about 120 degrees. Trigonal planar around this carbon, again, about 120 degrees. So let's look at our last molecule. Here we have 3 central atoms. Our first central atom is our carbon. And our carbon has 1, 2, 3 bonds. No lone pairs, so that's going to be a steric number 4. And it's going to be a tetrahedral shape. That's a little messy there, but that's an arrow coming out at you. We have a hydrogen, 3 hydrogens, and a nitrogen. Okay. Now look at the nitrogen. Our nitrogen, what's the steric number? We have 1, 2, 3, 4 electron domains, so a steric number of 4, 3 bonds, and 1 lone pair. That tells us that that's going to be a pyramidal, trigonal pyramidal shape. So with a trigonal pyramidal shape, we generally have a bond in the same plane as the screen, a bond coming out towards you, and a bond going away. Now, one of those bonds is a hydrogen. Our lone pair would be right up here, but we don't have to put it. And the other bond is going to be a carbon. Okay. So, now with this, now we've got to look at our third carbon. Our third carbon, or excuse me, our third central atom, our second carbon, our third central atom, has 1, 2, 3, 4 bonds, no lone pairs, so that's going to be tetrahedral. With tetrahedral, we have a bond, 2 bonds in the same plane, 1 bond going out towards you, right here, oops, and 1 bond going back away from you. This will be a hydrogen, and a hydrogen. Okay? Again, if you drew this in a different way, that's okay. There's more than one way to draw them. But take a minute and look at each individual geometry. Look at the geometry around this carbon. You should be able to see that is clearly tetrahedral. The geometry around that nitrogen, just focus on the bonds coming out around the nitrogen. That is trigonal pyramidal. And here with our second carbon, that is a tetrahedral shape. So be sure you're drawing each individual shape correctly, and then when we put them all together, we'll have the correct molecular geometry for that molecule.